Welcome to The Explainer. Think of me as your personal football strategist, but instead of the pitch, we are strategizing for the Cambridge Computer Science 9618 exam. Today, it's all about formation, tactics, and execution. We are mastering the absolute art of translating pseudocode to flowcharts. If you're prepping for your AS and A-level exams, you already know this isn't just about drawing a few boxes and arrows. It's about outplaying the defense, those tricky question barriers, and demonstrating the highly specific algorithmic thinking that Cambridge examiners are actively hunting for. We're going to break down exactly what those examiners want to see, using directly sourced insights. Let's get into it.
Now, why are we focusing so heavily on this? Because of this number right here. 15%. That is roughly the massive chunk of marks that drawing flowcharts from pseudocode accounts for in paper 2. This isn't some minor side quest you can just skip over. This is a foundational pillar of your exam strategy. Mastering this single skill area can completely shift your final grade. So we're going to treat it with the exact level of tactical focus it demands.
Here's our tactical playbook for today. 1. The 15% challenge. 2. Core principles and frameworks. 3. The technical methodology. And 4. Avoiding examiner traps.
Let's kick things off with Section 1, the 15% challenge, and how to maximize your points in Paper 2.
To guarantee those points, you absolutely have to leverage the method mark strategy. Imagine two hypothetical students taking this exam. Let's call them Alex and Sam. Alex just writes down the final output, messes up one variable, and scores 0. But Sam might also get the final output slightly wrong, but because Sam demonstrated a logical process, systematic processing, and incredibly clear working, the examiner awards method marks anyway. It's like getting points just for an amazing pass, even if the goal misses. The process is the product here. Real quick before we continue, subscribe to our YouTube channel Ace the Exams, at Ace the Exams IGCSE, to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Moving right along to Section 2, Core Principles and Frameworks, or what truly separates the top performers from the rest of the pack.
The biggest difference on the field comes down to generic memorization versus contextual application. Remember our student Alex? Alex overloads on raw computer science facts and tries to just memorize textbook pseudocode, regurgitating it onto the page with zero analysis. The syllabus actively penalizes this. Top-performing students use contextual application. They understand the concepts so well that when they see a completely weird, unfamiliar scenario on paper 2, they don't panic. They just adapt their tactics to the new context.
Take a look at this scouting report directly from the principal examiner. Candidates referencing cross-topic connections achieve significantly higher marks. This is huge. The underlying architecture of drawing a great flowchart relies on integrating it with the rest of your syllabus. Show those causal relationships. Link your flowchart logic to broader data representation concepts. It tells the examiner that you haven't just memorized a play, you actually understand the entire game.
Stop scrolling! Subscribe to our YouTube channel Ace the Exams at AceTheExams_IGCS to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to at AceTheExams_IGCS and turn on all notifications so you never miss our weekly exam strategy sessions. Okay, let's jump into Section 3, the technical methodology, your actionable blueprint.
This is where we execute the tactics. Algorithmic thinking demands a strict sequence. Step 1 is step-by-step decomposition, breaking that complex pseudocode down into its raw elements. Next, appropriate data structure selection. What kind of data are we actually dealing with here? Third, efficient code implementation, perfectly translating those steps into a highly efficient flowchart. And finally, rigorous testing. Mentally dry run that flowchart to prove it holds up under pressure. Building on that sequence, the absolute best candidates use this specific problem-solving framework: deconstruct, solve, evaluate. First, you deconstruct, identifying the core info and breaking it into steps. Then, you solve, systematically executing your analysis with clear working to lock in those method marks. Finally, you evaluate, checking your logic for reasonableness and justifying your choices. This transparent workflow is your absolute best defense.
So what does a top-tier evaluation actually look like? It means you don't just sketch the very first flowchart that pops into your head. You consider multiple solutions. You analyze algorithmic trade-offs. You explicitly identify how things like time and space complexity impact the performance. You acknowledge limitations, and you always justify your decisions with evidence. That critical analysis is exactly what pushes a grade to the top tier.
Now for Section 4, Avoiding Examiner Traps. These are the top mistakes you need to dodge.
Let's talk about where our other student, Sam, usually drops the ball. Sam often rushes and misses the specific requirements. Straight from the principal examiner reports, here are 3 classic traps. Number 1, using the wrong algorithm for the given context. This happens when you try to force a memorized play into a unique situation. Number 2, forgetting to check boundary conditions and edge cases. If your flowchart crashes at the extremes of the data, you lose marks. And number 3, providing answers that aren't specific to the actual question context.
I really need to emphasize this because the examiners issue a massive alert about it. Generic answers fail. You must always link every single point to the specific scenario given in the question. If the exam prompt is about a smart greenhouse temperature sensor, your flowchart in your working notes better reflect a greenhouse. Don't write a generic textbook loop that could apply to anything. Contextual application is everything. Failing to link your logic to the specific scenario is basically handing your marks back to the examiner.
We've mapped out a serious strategy today, from realizing the 15% weight of this topic to mastering the frameworks that absolutely guarantee method marks. So, my challenge to you is this. How will you adapt your exam strategy to capture every method mark in your next past paper? Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here.